Okay, good afternoon, class. So today we're looking at exercise 12.4, the odd numbers, which is on page 40. 40 to 411. Okay. So in this exercise, you can use a tree diagram if necessary. Okay, you'll see me use a tree diagram often. Okay. So in this exercise, okay, we just read that. What's wrong with you? Okay. So here we are told that the coin is tossed 3 times. Calculate the probability of getting 3 heads. So in a tree diagram, what this is going to look like, the coin can either be heads or tails. What is your probability for it being heads? Tails? So again it goes. It can be heads or tails. On your second toss, it could be heads or tails. Not so. It's half. Again, it can be heads, tails, heads, tails. Heads, tails, heads, tails. Not so. So, what's the probability here? Okay, so what are the outcomes? Heads, heads, tails. Not so. It is heads, heads, heads. It is heads, tails, tails. Heads, tails, heads. Then it can be tails, heads, tails. Tails, heads, heads. Tails, tails, tails. Tails, tails, heads. How many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Yeah, 8 different ways the coin can be tossed. Okay. The question says, calculate the probability of getting 3 heads. So 3 heads is going to be, a half times a half times a half, which is 1 over. You guys are getting that? You look at B. If a coin is tossed 6 times, so I'm not going to draw this, what's the name, extended 6 times. However, it will simply be, it's 1, 2, 3, 4, 5, 6 hits. So it's going to be half times, not 6, to the power 6. Or you're going to say half times, half times, half times, half times, half times, half, which is 1 over. Okay, you guys understand? See any confusion there? Not yet. Okay, let's go with number 3. Number 3, we are told that 3 out of every 10 cars in Johannesburg are white. Determine the probability that the next 3 cars driving up the road will all be white. So if I draw a T diagram for this, so the car could be white or not white. Okay. What's the probability of it being a white car? 3 out of 10. And not white? 7 out of 10. You see that? So they're talking about the next 3 cars. So this is the first car. Okay? The next car? What's the probability of it being white? 3 out of 10. Not white? 7 out of 10. The first car is not white. The second car could either be white or not white. Which is 3 out of 10, 7 out of 10. Or 0,3 and 7 is the same. The next car could be white or not white. White or not white. White or not white. White or not white. You all agree with that? So this is what would the probability on this branch be? 3 out of 10 and 7 out of 10. This is going to be 3 out of 10 and 7 out of 10, 0,3, 0,7, 0,3, 0,7. Remember, if you add this up, it must always give you 1. Okay. So what is the probability that all 3 cars is going to be white? So it's going to be 3 out of 10 times 3 out of 10 times 3 out of 10, which is 27 over. What's the probability that none of the cars will be white? So, the probability of non-white, non-white, non-white. Not so. So what's the probability of not white? 7 out of 10. And not white? 7 out of 10. And so on. So it's going to be 7 out of 10 times 7 out of 10 times 7 out of 10. Which is 343 over 1000. Okay, any confusion there? Let's look at C. What's the probability that at least one of the next 3 cars will be white? At least one. So if it's at least one, it can be the probability of white, not white, not white, not so. Plus the probability of not white, white, and then not white. Plus the probability of not white, and then the white one. Plus. So if it says at least one white, then can there be 2 whites? Yes. There will be probability of white, white, not white. Plus the probability of white, not white, white. Plus the probability of not white, white, and white. Can all 3 be white?
Yes.
Yes. So it's plus the probability of white, white. Which means to say how many is there? 1, 2, 3, 4, 6, 7 cases. But how many are there in total? 1, 2, 3, 4, 5, 6, 7, 8. So this is actually the complementary rule. Can you see that, people? This one that is not here. Which one is not here? There we go. So it's 1 minus the probability of not. That's the only one that's not here. Okay? So in other words, this should simply give us 1 minus, and that we've worked out as 343 over 1000. And that gives us 1 minus 657 over 1000. Is that correct? 657 over 1000. People, if you had worked this out, if you had gone white, which is 3 over 10, multiplied by 7 over 10, multiplied by 7 over 10 plus 7 over 10 multiplied by 3 over 10 multiplied by 7 over 10 plus 7 over 10 times 7 over 10 times 3 over 10 plus 3 over 10 times 3 over 10 times 7 over 10 plus 3 over 10 times 7 over 10 times 3 over 10 plus 7 over 10 times 3 over 10 times 3 over 10 plus 0,3 times 0,3 times. If you do all of that and you add it together, you should get an answer of 657 over 1000. Okay. So, would you get the same marks if you had gone this method? Yes. Yes, Michael.
So is that a rule or something?
Sorry?
Is that a rule?
That's the rule. Is the what rule do we call this? Complementary rule. Okay. People, number 5. A bag contains 16 counters. 6 are red, 7 are green, and the rest are blue. So 16 counters, red, green, and blue. So if 6 are red, what's the probability of it being red? 6 out of 16. Green? 7 out of 16. Blue? 7 and 6 give you 13, so it's going to be 3 out of 16. Remember that this must always add up to 1. You guys understand? A counter is drawn at random from a bag. So they put all 16 counters in the bag. You don't see what you do. Okay? The counters is placed at random in a bag. Okay, a counter is drawn at random from a bag and then replaced before the second counter is drawn from the bag. Which means to say, if I draw the one, I record the drawing, and I put that one back. So how many counters is again in the bag when I do the draw? 16 again. Not so. So what happens is, and this is the first draw, no? On the second draw, it can either be red, green, or blue. The same probability. Not so. So to make it a bit bigger. And this is the red, green, blue. So red was 6 out of 16, green was 7 out of 16, and blue was 3 out of 16. Okay. That's on the first row. So it can be red, green, and blue again. So 6 out of 16, 7 out of 16, 3 out of 16. You understand? Red, green, blue. Red, green, blue. Okay, which is again 6 out of 16, 7 out of 16, and 3 out of 16. Okay, it's very cramped here, but you all know it's over 16. Huh? 6 over 16, 7 over 16, and 3 over 16. Okay. Determine the following probabilities. Both counters are green. Both counters are green. So, it's going to be 7 out of 16 multiplied by 7 out of 16. Can you see that, people? The probability is going to be 7 out of 16 times 7 out of 16. Which is 49 over 264. Which is 16 squared. 256. That was a way off, no? Let's look at B. At least one counter is green. At least one counter is green. So what is the options? What probabilities must be considered here? At least one counter is green. So it can be red, green, not so. Plus, it can be green, green, and green, red. Or, sorry? I got green, green. Blue, green. Okay. Plus,
So there was green blue plus green
blue, green, yeah? Green, blue. Plus, green, red. Oh, I wrote this one. Oh, yeah, you got green. Okay. What's going to happen here? So that will simply be, how many is here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this. Now going to go with the complementary rule. Okay, so what do I say? Probability of green, red, green. It's going to be 6 out of 16 plus times 7 out of 16. No? Plus. Green, green. 7 out of 16 times 7 out of 16. Plus. Green, red. 7 out of 16 times 6 out of 16 plus. 1, 2, 3. Plus blue, which is 3 out of 16 times green, 7 out of 16. Plus green, blue, 7 out of 16 times 3 out of 16. One set the calculator. What number is this?
Five.
Oh, 5. Okay, 6 out of 16 times 7 out of 16 plus 7 out of 16 square plus 7 out of 16 times 6 out of 16 here plus yes. Must be 16, huh? Is I made a mistake there. But it's supposed to be 16. One 175 over 256, is that correct? Huh? Yeah. 175 over 256. Okay. On top. On top. On top. You checking my right? Good. Right, let's go with, there's more something. It says, determine the probability if both is the same color. Both counters are the same color. What number is the 7, huh? Not 7. Okay. So let's look at C. C says both is the same color. Okay. So which probabilities must be considered? It can be green, green, plus red, red, plus blue, blue. So green, green. 7 out of 16 times 7 out of 16 plus red, red, 6 out of 16 times 6 out of 16 plus blue, blue, 3 out of 16 plus the times. So it's 49 over 256 plus 36 over 256. Work it out, just written it as one denominator, is the same thing. Plus 9 over 256. Did you 47 over 128? Okay. You okay with that? $120. Let's look at D. D says none of the counters are which is drawn are blue. So that means to say I'm taking all this out. That out and that out. So what are we left with? Red, 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 green, green, red, green, green. That's all I'm left with. You all agree with that? Okay, so I just need the space here. Okay, so that's D. So we see the probability of red, red, plus the probability of red, green, plus the probability of green, red, plus the probability of green, green. So red, red. So 6 over 16 times 6 over 16 plus red, green, 6 over 16 times 7 over 16 plus green, red, 7 over 16 times 6 over 16 plus green, green, 7 over 16 times 7 over 16. Now gives us 6 over, so that could give us, that will be 36 over 256. No? Plus. 6 times 7 is 42 over 256. Not so? Plus. That's going to again be 42 over 256 plus 49 over 256. Gives you 169 over 256. Okay, any confusion there, people? Okay. So that was number 5. Let's go to number 7. Number 7, we are told the probability of any one student passing the first board exam on the first attempt to qualify for a chartered accountant is 50%. 53%. So, if the chance for them passing on the first attempt is 53%, attempt 1 is 53%, so 0.53, then what is the chance of them not passing? 0.46. Remember, this must always add up to 1. The probability of any one student passing the second board exam on their first attempt is 83%. They pass again. So that's going to give you 0.83, 0.17. So that again adds up to 1. Calculate the probability that any one student chosen at random will pass both supposed to be exams on the first attempt. In other words, you're going to work out the probability of pass and again pass. So the probability of PP is going to be 0.53 multiplied by 0.83. 0.53 multiplied by 0.83 gives you 0.4399. Check if that's correct. 0.4399. Okay. Any confusion there? Number 9. A die is thrown 3 times. Calculate the probability of throwing 3 sixes. So what's the probability of you tossing a 6? 1 out of 6. And no 6s? 5 out of 6. Can you see that? So it's tossed 3 times. 6 no 6. 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 Okay. And of course that's 1 out of 6, 5 out of 6. 1 out of 6, 5 out of 6. 1 out of 6, 5, and so on and so on. Okay. Because of the space, and I'm drawing you and writing, you don't see it. So you have to write all of it. Okay. People, number 1. What's the probability of throwing 3 sixes? 1 out of 6 times 1 out of 6 times 1 out of 6. Not so. Which is 1 over 216. Number 2. No 6s. So no 6s will be 666, 666. Not 666. Will be 5 out of 6 times 5 out of 6 times 5 out of 6. Or 5 out of 6 cubed. Which is 125 over 2. Number 3. At least 1 6. So if it's at least 1 6, it's going to be the complementary rule. Why? Then I can just say it's 1 minus no 6. 1 minus the probability of no 6s. Okay, which is going to give me 1 minus 125 over 216. .91 over 216. Correct? Sorry? Otherwise, what you could have done was, you could have said, it's going to be the probability of 6, no 6, no 6. Then the probability of no 6, 6, no 6. Then plus the probability of no 6, no 6, and 6. Then you go. 2 6s. Probability of 6, 6, no 6. Probability of 6, no 6, 6. Probability of no 6, 6, 6. And would be 3 6s. Probability of 6, 6, 6. And then you add it all together. That is why it's very useful to know when to apply the complementary rule. Okay? If that is A, then I'm sure there's a B part of the question. A die is thrown 5 times. What's wrong with this, people? Many things, okay? So what happens is, this gets extended further. That is 4. And then they extend it again. And so on. Right. You guys understand? Again, number 1. A die is thrown 5 times. Calculate the probability of 5 6s. Probability of 1, 2, 3, 4, 5, 6. 1, no. 5 6s. Which is going to give you 1 out of 6 times 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 1 out of 6. Which is 1 out of 6 to the 5. Which gives me an answer of 1 over 7776. Is that correct? 1 over 7776. Number 2. No 6s. So that's going to give you 5 over 6 times 5 over 6 times 5 over 6 times 5 over 6 times 5 over 6, which is 5 over 6 to the 5. Three one two five. 3,125. Let's look at number 3. At least 1 6 is the same as saying 1 minus no 6, which is the complementary event. Not so? Which is going to be 1 minus 3125 over 7776. 1 minus that gives you 4,651. 4,651 over 7776. Is that correct?
Yes.
There we go. Easy, no? Can't help that maths is so easy. People, we are told that data gathered from a testing station for car license show that 80% of the applicants pass the learner's license the first time. But only 40% pass the practical driver's test the first time. Calculate the probability that learner chosen at random will pass both tests the first time. So, 80% of the applicants pass the learner's license the first time. Learner's license and does not pass learner's. Okay, we don't need that. So pass and not pass. So it's going to be 80%, so 0,8. Not pass, 0,2. Then, and only 40% pass the practical. Now if the person doesn't pass the learner's license, can they do the practical? No. So then I'm not going to branch this one off. Can you see that? So they must go practical. Wait, let me see. Okay, so pass, so okay, it's not going to make a difference here anyway. Because it's going to follow this branch anyway. So if it 40% on the practical, he passed the practical the first time, so 0,4. Was it failing the practical? 0,6. So they want to know what's the probability of them passing both on the first attempt. So the probability is going to be 0,8 multiplied by 0,8 times 0.4 gives us 8/20. Is that correct? Anita, what's wrong? Now I look like you want to say something. That is your look. Right, so that brings us to the end of exercise 12. The full lesson can be found in the description box below.